OSPF is a link state routing protocol because the routers use OSPF to share information with each other about the state of their links. All routers start sharing information they have about the networks they are connected to, the cost of the interfaces, they find out about any networks that have gone down, any new networks that have appeared within the OSPF domain, and so on. And this is because they create something called a link state advertisement. And this is the job of the LSA to share information about the OSPF topology with all the routers. But there are quite a few different types of LSAs, which we will talk about now. We will take a look at the 6 main ones used by routers and switches today, which are types 1, 2, 3, 4, 5 and 7. LSA type 1 is called a router LSA and is sent within an area. And every OSPF router creates a type 1 LSA for itself and then floods the LSA throughout the same area to its neighbour routers. And the neighbour routers send it on to their neighbours so that everyone has the same information about the area, with information such as its interfaces, the cost of those interfaces, its networks, its router ID and other information as well. ABR routers, which we'll talk about shortly, are a bit different, where they create a type 1 LSA per area as they are connected to multiple areas, but internal LSAs like these ones in the middle just create the one LSA about themselves. And each router will generate a router link for all of its interfaces. So all OSPF speaker types generate type 1 LSAs. They are only advertised in the area, which includes the router's own topology information and routing information. So that's type 1 LSAs. Let's move on to type 2. Type 2 LSAs are called network LSAs, and like type 1 LSAs, they are only generated and sent within its own area. And type 2 LSAs, the network LSAs, are generated by the designated router only, or the backup designated router if the designated router is down. And they include all network information that is connected to the DR. The DR will present the subnet and the interfaces connected to that subnetwork. A DR and BDR is elected for every multi-access segment in that area, which is per subnet. So for every subnet within the area, there will be a designated router and a backup designated router elected. And it's actually the interfaces of the routers that are elected. In the diagram, it shows R5 is the DR for the 10.0.0.0/20 subnet. And although it's also connected to 10.0.16.0/20 subnet as well, it's not the DR or the BDR for this subnet. The DR is R2 and the BDR is R1. The DR and BDR are elected based on router priority or the router ID, which I have covered off in another video, and they are there to handle all the LSA exchanges, the OSPF updates for the segment basically. This means all routers don't have to bombard each other with OSPF traffic, they just let the DR and the BDR deal with the updates. LSA type 3 is called a network summary LSA. This is because it's generated by the area border router or router, and one of the main jobs of an area border router is to advertise the subnets as summary networks for its areas when advertising them to other areas. So rather than advertising many prefix 24 subnets, you can summarise them with a single summary network, such as with a prefix of /20. You need type 3 LSAs to be able to forward traffic into different areas. Just to note, you have to actually summarise the networks. This isn't magically done by default, and you don't have to necessarily summarise them. It can advertise them with their specific subnets, but the feature is there and it should be used where possible. And it can do this because an area border router has a leg in multiple areas. It will have an interface into the backbone area, which is area 0, and into other areas such as area 1. Type 4 LSAs only make sense once type 5 LSAs are understood, so it's better to describe type 5 LSAs before moving on to type 4s. And with a type 5 LSA, an LSA type 5 is called an autonomous external LSA. LSA type 5 is generated by router that has non-OSPF routes, which is external to the autonomous system boundary router, the ASBR, and it is used to advertise the external routes outside of the autonomous OSPF system, injecting them into the OSPF domain. These external routes can be static routes or another dynamic routing protocol like BGP or EIGRP. And these networks are injected into OSPF via a term called route redistribution. And this is why the type 5 LSAs is known as an external summary, as it can also summarise the networks like type 3, but it's advertising external networks into OSPF, hence the name external summary. And with these two networks here with the prefix of /24 here, they can both be summarized with a prefix of a /23 instead. So with the ability to summarize, it means that you don't have to advertise as many subnets into the OSPF domain or between the OSPF areas as in the case of an ABR, which means it just makes things a lot more efficient in terms of how many networks advertised on the routing tables. The summary network can then be propagated into the OSPF domain and into all of the topology and routing tables across the hundreds or maybe even thousands of OSPF routers within the OSPF domain. And finally, an LSA Type 5 is created for each external network being redistributed into the OSPF domain. The Type 4 LSA is called an ABR summary LSA, and it's generated by the ABR to broadcast the location of the ASBR. So on the screen it's generated by R3, which is the ABR, to broadcast the location of R6, which is the ASBR. Now to drill into it a bit more so we can understand exactly what's happening here, the ASBR generates Type 5 LSAs like we've seen on the previous slide, and it says to get to these 172.16 networks, send the traffic to me, to my router ID of R6, which is all good within the area Type 5 LSAs have been generated in. They know how to get to 6.6.6.6 R6. However, when the Type 5 LSAs reach into other areas, such as Area 1, routers in Area 1 get to find out that to get to the 172.16 networks, go via the ASBR R6, which is a router ID of 6.6.6.6, for example. So go via that router ID. But they don't know how to reach the ASBR 6.6.6.6. And this is where the ABR generates a Type 4 LSA and says to get to 6.6.6.6 R6 router, send the traffic to me, the ABR, which is R3. And because the ABR already knows how to get to R6, because they are in the same area, the ABR has legs in all the different areas, the ABR knows how to forward the traffic to R6. So with the ABR, it has a topology map, which is the link state database of all the areas it's connected to. So the ABR knows how to get to the ASBR, but the routers in Area 1 don't know how to get to the ASBR without the ABR telling them where it is. So to cover it off very briefly again, the Type 5 LSA says traffic for the 172.16/24 networks are reachable via R6, which is the ASBR in Area 0, but the routers don't know how to get to the ASBR and need Type 4 LSA for this. And Type 4 LSA provides location of the ASBR. The ABR tells the routers in Area 1 to get to the ASBR you have to go via me, which is router 3, the ABR. Type 7 LSAs. To understand the Type 7 LSA, you need to understand the three special kind of areas: Stub Area, Totally Stubby Area, and Not So Stubby Area. Let's start off with Stub Area. When an area becomes a stub area, the area no longer accepts external routes outside of the OSPF autonomous system, so it blocks Type 4 and Type 5 LSAs we just previously discussed. And if any routers in the area need to reach those external routes, they would reach them via a default route. And the reason for this is because since there is only one exit point via the ABR R3, so what's the point of these Type 5 and Type 4 LSAs to reach the external networks advertised by the ASBR in Area 0? We can just replace them with a default route. Anything for external routes, just send them to the ABR since there is only one exit point anyway. So it works in areas where there is only one exit point. And once the area is turned into a stub area, external routes are suppressed through the ABR. It only supports Type 1, 2 and 3 LSAs, no more Type 4 and 5 LSAs in the area. And you may be able to see the whole point of a stub area. It reduces the topological size of the database inside the area and reduces some of the OSPF overhead on each router. So it makes things a lot more efficient. And from an IP routing table perspective, the external routes will disappear in the routing tables and be replaced with a default route. Now, if we make Area 1 a totally stubby area, we would also block Type 3 LSAs. So now Type 3, Type 4 and Type 5 LSAs would be blocked, only allowing Type 1 and 2 LSAs in the area. In other words, it stops advertising out summary LSAs for all of the other networks within the other areas, and it can do this absolutely fine because it's already providing a default route as in the case of a stub area. And from a routing table perspective in Area 1, it would block all the inter-area routes from showing up. And again, it makes sense because why does a router need to know about the routers and their networks in other areas when there's only one exit point anyway? It cannot reroute the traffic, so it may as well just have a default route. By the way, again, a summary route which is blocking is a type 3 LSA, but these are routes that are coming from other areas. Whether they are actually summarized by the ABR or not, they're called summary routes. Now, to summarize all that, there's no more type 3, type 4 and type 5 LSAs. It's just a default route in Area 1. Now the type 7 LSA, it's called an NSSA external LSA, and it is generated by the OSPF router within an NSSA area, not so stubby area. So currently the area is now a totally stubby area, which we just discussed, which is blocking of type 3, type 4 and type 5 LSAs. But what if later down the line one of the routers, like this new router in the top right, needed connectivity to a cloud provider, let's say over BGP. Usually how we would do this is redistribute them into OSPF. The problem is, however, type 5 LSAs are being blocked because it's a stub area. So as a way around this, the OSPF camouflages them in a type 7 LSA instead. So the type 7 LSAs are really type 5 LSAs camouflaged or masked as type 7 LSAs so that the area doesn't block them, and now the area has become an NSSA area, or a totally not so stubby area. It's basically a stub or totally stubby area, but lets you redistribute external routes such as static routes, BGP or whatever. It lets you redistribute them into the area as type 7 and right through the area to reach other areas. But to reach the other areas, it becomes a type 5 LSA once it reaches the other side of the ABR router. From the image here, it's type 7 LSA as the router is blocking type 5 LSAs here. So it needs to be sent via a type 7 LSA, I've called it T7, but once it reaches the other side, it becomes a type 5 LSA again. And just for completeness, just to cover off the missing piece, type 6 LSA. This is a multicast LSA where data is addressed to a group of destination devices. And type 6 LSA is not supported or used by Cisco, as PIM is used by Cisco for multicast traffic. PIM stands for Protocol Independent Multicast.